Hello people and welcome to Basic Chemistry Explained. Today we'll be talking about elements. This is the periodic table. It lists all the elements that have been discovered. A good way to impress your friends is to memorize all the elements in order. Therefore, I strongly encourage you to visit the ASAP Science periodic table song. It will be down in the description. You might be wondering, what are all these boxes for? Well, let's take a closer look at the box for oxygen. Here it is, the box for oxygen. In the top right corner, we have the atomic number. As you can see, it is an 8. This indicates that there are 8 protons in an atom of oxygen. Then, in the middle, we have this big O. Well, O is the symbol for oxygen. Instead of writing oxygen, when writing out chemical equations, we will just be writing O instead to indicate oxygen. Then, at the bottom, you have the atomic weight. It basically tells us the mass of this atom. Well, some of your fellows might be wondering, what is a chemical element in the first place? Well, a chemical element is a substance which every atom has the same number of protons in it. Imagine you have a jar with, let's say, 6 different atoms, and they have all the same number of protons in them. Let's say 3 protons in each. Those will be the same element. Now you have a jar with another 6 atoms, and some of them have 3, and some of them have 2 protons in them. Those will be a mixture of elements. There will be different elements from each other. Okay, now let's suppose that you have 4 atoms. The first one is the original atom with 2 protons, 2 neutrons, and 2 electrons. The second one is the same element but different isotope. It still has 2 protons, but now it has 3 neutrons. Now, as you know, the number of neutrons determines the isotope and number of protons the element, so it's same element, different isotope. The third one is a different element all over because 3 protons and 2 neutrons. At first it looks like it might be the same because it has the same number of neutrons, but remember, neutrons determine isotope, not element. It has different number of protons, that's why it's a different element. Now your last atom happens to have the same number of protons and the same number of neutrons, but it has less electrons than the original one. It's an ion. It's a positively charged ion because it has lost an electron. Now let's take a closer look at the periodic table. At first it looks all confusing because there's so much to it. But let's break it up. First, the top part. As you will later realize, the periodic table is a wonderful tool because elements that are close to each other on the periodic table have similar properties. The first column includes the alkali metals. These are very reactive, and in future episodes I will explain why. Next to them we have the alkaline earth metals. Next to them we have the transition metals. They are shiny and have high melting points as well as a high density. Instead of going over each column by itself, we're gonna look at the more general names for these. Here is this block up close. First we have the metalloids. Where they are is actually really easy to remember because they make up stairs. Ouch! These are nonmetals. The second last column has a special name for them. They are halogens. These are extremely reactive nonmetals. Then we have the last column, which we call noble gases. They're sometimes called inert gases. The properties of these are that they don't react with anything at all. Like at all. Seriously, they don't react with anything. So let's look at the bottom part of the periodic table. First, at the top we have the lanthanides, and the bottom row we have the actinides. These aren't important at all, but it's good to mention them. Now for the important stuff. First up, we have hydrogen. Hydrogen has 1 proton and 1 electron. This is the only atom that has no neutrons. Then we have carbon. Carbon has 6 of everything. Then we have nitrogen. It has 7 of everything. And then it's diatomic. What again? Well, diatomic elements are those that come in pairs of two atoms. They hate being alone, so they stick together when they're not stuck in any other compound. This is our favorite oxygen with 8 of everything. It's also diatomic, which explains why you always see it written as O2, because there are 2 oxygen atoms. Then we have dear sodium, which is 11 of everything and diatomic. Then we have dear chlorine, which has 17 of everything, and it's diatomic. Then we have bromine, which has 35 of everything, and is diatomic. And last but not least, we have iodine, which has 53 of everything, and guess what? It's diatomic as well. No, most elements are not diatomic, but these are pretty important, and that's why I listed them. We will see more of them in future videos. There wasn't any real-life footage in this episode, but I promise that the next one will be full of it.